Hi everybody, here's a quick overview on what you're going to be doing with this assignment, layers of the atmosphere graphs. You're going to want to increase and decrease the size of a lot of these pictures so that you can read them a little bit better, just like I do when I'm on here. And if you look at this picture, you can see that we have those layers and pauses. We've got the troposphere, the stratosphere, the mesosphere, the thermosphere, and the pauses are where that temperature change occurs. It's where it reverses direction. So we have the thermosphere that gets colder as we go up, and then the stratosphere gets warmer as it rises. And then at the stratopause, it gets colder again, in fact, very cold. In fact, if you follow that straight down, it's about 80 degrees, negative 80 degrees roughly. And that's what you're going to be doing. You're actually going to be looking at these graphs and doing some interpretations. So I might ask you, where are you going to find the northern lights, the polar lights? Well, that's going to be somewhere in the thermosphere. Where would you find Mount Everest? Well, that's the troposphere. Where would we live? Well, the troposphere. Where's the bulk of the atmosphere? Well, the troposphere. Or the bulk of the mass of the atmosphere. Those are the things you're going to find out about. But you need to look at it, and you might need to use some elevations, and you might have to do some estimations. So if the tropopause is here at 10 and it starts at 0, well, you need to look, and that's kilometers. That's 10 kilometers. But the stratosphere ends at the stratopause, and you're going to have to estimate that that's roughly maybe halfway between the 40 and the 60. So let's say 50. Well, that means it starts at 10, it ends at 50, so that's 40 kilometers thick. So you're going to need to do some math like that. Go ahead and read this little bit of a blurb. And now here's another graph with the same information, but on it we have three different things that we're really looking at here. Again, we have temperature on this graph. And then here we have atmospheric pressure. So this tropopause is the same elevation all the way through all three of these graphs. And you'll notice that only at the tropopause are you actually hitting this water vapor. Really, by the time you get above into the stratosphere, there's not nearly the amount of water vapor that we have down here in the troposphere. But you can also look at atmospheric pressure. Look, we start here at sea level at 1013.2 roughly millibars of pressure, and it drops drastically as you go up until there's hardly any pressure once you get past the mesopause and the thermosphere. So there is and there are particulates of gas up there. They're just really far apart, far enough apart that we don't really measure the pressure, as it were. We'd say it's the absence of pressure. People will say the vacuum of space, but in science there's really no such thing as a vacuum. It's just positive and negative pressures. So I need you to pay attention to the fact that this 50 goes across this graph as well as the pressure graph. So if you're trying to find a height somewhere in here, let's say where we're at 1, you'd follow this up until you think it crosses, and you'd realize that somewhere in the mesosphere, and I could figure out roughly that it's maybe, okay, that goes 50, 60, 70, 80, 90, so maybe about 60 is where that goes. So pay attention to the side markers to see how to do this. Again, we're back into a map where it should look familiar. It's got a lot of the information that you've seen before, but I didn't want you to have to scroll up and down, so I just put it down here and you can see it. And I'm going to ask you some more questions, like, in which layer do airplanes fly? And I guess I should qualify that. Which layer do jets fly? So we're going to go up here past. In this case, they're really talking about the top of the troposphere. So if you told me the top of the troposphere or the bottom of the stratosphere, if you're a jet plane, you wouldn't be wrong. If you're talking about a little propeller plane and you told me it's in the stratosphere, then we've got a problem. So look at those pictures and go through. This is looking at the ozone layer, and you'll notice that it blocks ultraviolet radiation. That's remember our sunscreen. Without it, we're in trouble. Cancers and things like that would be much more prevalent. And again, I've got some measurements here for thicknesses, but I'm really trying to look at more of what's happening with this ozone layer. So we've got a little bit of reading and a few questions. Now, keep going through the questions. All this should look familiar. Here's again, I don't want you to have to go back and forth. I just put it down here so it was very clear to see. So which is the coldest temperature occurs at an altitude of about what? So you're looking for the coldest. It's right there. Estimate that is 50, 60, 70, 80. At about 80 kilometers is going to be the coldest temperature because it's the farthest to the left. And a positive 100 is much warmer than negative 100, right? All right. A few more questions. Same set of graph, more information about it, where I'm starting to ask for thickness. I'm starting to ask what pause occurs at -60. So again, you have to read some graphing information. If you have questions, as always, ask.